Hey YouTube, in this video we're going to kind of work out some solutions here for a given angle and trying to determine a reference angle for that given angle. So really quickly, let's kind of refresh our memories on what a reference angle is. We say that the definition of a reference angle is the smallest angle that the terminal side of an angle makes with the x-axis. So we'd say given any angle here, you can see this angle in black or red depending upon positive or negative. There's an inner angle here that we refer to as the reference angle, and it is the smallest angle that this terminal side makes with the x-axis. So for instance here, a 45-degree angle, its terminal side makes a 45 with the x-axis. If I were to go over here to like a 135, its reference angle is also a 45-degree reference angle, well, because it makes a 45 with the x-axis. So you can see that the biggest this reference angle ever gets is 90, but otherwise it's always between the terminal side and the x-axis, and it's always acute and it's always positive, which is kind of a neat thing about it. So what we're going to do in this video is use the informal method of finding reference angles, which is basically me suggesting that you always just sketch an image. So what we're going to do is we're going to sketch the original angle here. Now 390 degrees, I think that it's fair to say that when we navigate, at least graph angles or sketch angles, that is, we're always navigating using these values here. So I find myself saying, 390, well, that'd be one full rotation plus another 30. I can imagine a 30 kind of taking off at this angle right here. So we say, here's my 390 degree angle. But the simple fact that I said that it would be 30 beyond 360 kind of is nice, because that is the reference angle, of course, that we're looking for in this particular case. We say 30 degrees is our theta prime. And of course, we use theta prime to represent the reference angle for the angle theta. Just like if we had an angle alpha, we would say its reference angle is alpha prime, okay? Just wanted to say that. Sorry. So 21, negative 135 degrees. You can see how this would lie in the third quadrant here. Now, negative 135, we'd say, well, somewhere in between a negative 90 and negative 180. As a matter of fact, it splits the difference. And so it's helpful kind of to know that, because if we know this is a negative 135 and that splits the difference between these two, then I know that this reference angle right here, theta prime, has to be a 45. So now these last two that I want to look at, these are just radian measurement here. Nothing hard about these. It's just that we have to embrace graphing those in radian measurement. So when I say radian measurement, I say let's go graph these. The one thing I suggest to people to remember is always that this is pi and this is 2 pi radians. So that being said, what we're going to do, since we're dealing with pi thirds, I'm going to convert these to pi thirds. It's really easy to do. You just make this one n pi nths, or in this case 3 pi thirds. We want thirds. And if I convert this to thirds over here, it's in wholes, we would say that this would be 6 pi thirds, which is the same as 2 pi. So really 2 pi thirds, when you think about pi as being the same thing as 180, then a third of 180 is 60. This is really two 60-degree rotations. So we're going to say of our pi up here, we're going to split it up into 3 equal sized pieces, each one 60 degrees. We're going to say we have 2 of these. So the nice thing about radian measurement is once you get your angle sketched, and we can say that this is a 2 pi third or 2/3 of pi rotation here, you can just see that the reference angle is just this leftover portion right here. And the neat thing about it is just a pi third, it's that leftover pi third. So our theta prime here is pi third. And likewise with this here, negative 11 pi 6. Again, let's just throw this sketch together pretty quickly. It's negative, so I'm going to call this negative pi. I'm going to call this negative 2 pi. We're going to rotate clockwise. And since we're dealing with 6, why don't we go ahead and convert this to negative 6 pi sixths. And we'll call this negative 12 pi 6. So easy to modify. But basically, negative 11 pi 6, you could see how that would be just a pi sixth or a 30-degree rotation short of the full 12 pi 6 here. So if this is negative 11 pi 6, neat thing about it is our reference angle, which is this leftover portion right here, theta prime, this is going to be equal to a positive just pi 6 rotation. So we say pi 6 rotation. So that's our reference angle. In the next video, we'll take a look at how we can use reference angles to easily evaluate trig functions for values. Cheers.